So this is Red Team automation, infrastructure and payload development. My name, as I was saying, is Andre Lima. I work at PwC Norway. Have been doing this for 12 years. Red Team operator, researcher. Have worked around the world. In Portugal, Australia, and now finally settling down in Norway for sure. And yeah, you can reach out to me on LinkedIn. If you want to check some of my previous presentations, that's the link. And if you're interested in what I do and want to follow, just I'm on X as well. It's still weird to say that. Also, I'll be sharing the slides in the end, so don't worry about taking pictures and all that stuff. You'll have those in the end. So yeah, today we're going to talk about, because I understand there's a mix in terms of, in the audience, in terms of experience. So I'm going to do a little intro on Red Team infrastructure. Then I'm going to talk about my implemented solution, big FYI, work in progress. But I'm going to talk about the infrastructure, payload development, and future development that I want to do on it, and some conclusions. So a little intro into Red Team infrastructure, just some design considerations that you should have, and the reason why you will often see this type of architecture whenever Red Team infrastructure is mentioned. The things you are looking for here are resilience and concealment, and the whole point is if you have a payload and it's reaching out back to a C2 server, you want to have the resilience of having more than one redirectors. Those redirectors do nothing more than redirect traffic to the backend server. That could be a C2 server, that could be a payload server. And what you want is, if the blue team is able to detect that type of traffic and it flags it as suspicious and it tries to block it, you want to have a list of options, in this case, the list of redirectors. So if you block redirector 1, it just automatically moves on communicating on redirector 2, and then if something happens on redirector 3, and so on. Now, usually, what you want is to have some sort of separation of duty. Again, gives you more resilience, but you'll often have this logical architecture regarding, for example, your payload, and then another one for the C2 server, and then maybe another one for the phishing infrastructure, for example. You want to have these separated because you don't want to have the blue team just block one IP and all of a sudden it blocks your entire infrastructure in terms of functionality. But there is a problem with this, which is, as you might imagine, if you are tasked with setting this whole infrastructure up, then this becomes a huge load of work, and you do not want to do that manually. I love sysadmins, but this is not the job. So I do prefer to spend my time hacking. So yeah, the solution is obviously, given the problem that too much work, instead of spending too much work in sysadmining, you probably want to take some of that time and actually put in to what is more valuable to the client and actually do more hacking in that sense. So automation is definitely the way to go. Now, just a quick note on why this type of projects is interesting. Multiple tech options, different design options, very customizable, new tech integration. One of the things that I've always loved to do, even though I'm more connected to the security industry, is to go randomly to conferences, IT conferences usually, where sometimes developers, infrastructure, whatever, and just learn about new technologies and often wondering, how can I integrate that into what I know and how could that help me? And in that sense, it is incredibly interesting to just go deep into some of the technologies because obviously most of us understand, for example, the concept of DevOps, but have you actually ever gone deep into one solution and tried to actually have it work? So this is why this type of project tends to be like super interesting. You just learn something new, and immediately you might have new ideas. I don't know, for example, Mojo is a new language, but on the surface, if you look at it, you might just quickly put it aside as, oh, it's just an AI language kind of thing. But actually, when you dig deep into it, it doesn't relate to this, but it's just an analogy here. But when you dig into it, you start realizing that actually it's a full purpose language. And if you understand how much quicker it is and how it does it, you can quickly have the idea of maybe redesign Hashcat. I don't know, hash cheetah or something. And down the line, maybe that's an interesting project that might come up just because you had the idea to go to a conference and hear about Mojo, that seemingly unrelated. So if you want to read more into this, there's a lot of technicality in terms of what software to use, for example, in the redirectors. There's more considered dumb redirection when you usually go OZ layer level, level 3, 4, where you're thinking about IPs or maybe TCP, UDP, that kind of redirecting. But then there's also the considered smart redirection, where you tend to, it's usually something related to, it has the ability to read into the layer 7. So HTTP protocol, look into the bodies of the request and decide what to do. Sometimes EDRs and specific tools that sandbox some payloads will do requests and will identify themselves in the agent or in whatever HTTP header, and you might want that flexibility. So in that sense, you might want to use something like mod rewrite. In my case, I'm a minimalist at heart, so at this point I'm still using IP tables, but later down the line, as I see the need for it, I will definitely improve it. So yeah, definitely some really good references. Now I'm going to talk about the implemented solution. Again, big FYI, ongoing work. So basically, it comes down, in terms of infrastructure, it comes down to a Python wrapper that runs Terraform to set up the infrastructure, and the Terraform in itself has Ansible as well for provisioning. So if I need to install an Apache server kind of stuff, that will be done with Ansible, but setting up the whole VM and redirectors and all that stuff will be done with Terraform. The reason why you want to wrap this up in Python is that you will require, for example, when I do DevOps, I'm using GitHub Actions. And what that means is I will eventually down the line have to trigger a workflow. And you can do that in the GitHub, using the GitHub API. To do that kind of stuff, I need not only information that is given to me as output from Terraform, namely the public IP addresses from VMs, but also, obviously, the API keys and everything to communicate and set up the whole DevOps, which I'll talk more ahead. There's also I want to integrate Uptime Kuma, that's K-U-M-A, just because it looks interesting, so I got into it. It doesn't mean necessarily it's the best, just FYI. But the whole point is you want to set that up, usually with Terraform and Ansible, and install it. But then you need the API, the Python, to again reach out to it through the API, through its API, to feed it the servers that you want to monitor and how you want to monitor them. That's a bunch of Python requests that you do. So these are some of the options that it does. I'm using the click module on Python. It just makes things a lot easier. And that's an example of the thing running. It's not that interesting seeing it live. It takes a lot of time A lot of time is in 10, 15 minutes, maybe, depending on the number of redirectors, but on the Terraform applying part. But yeah, and those are some of the tools that I'm using GitHub Actions. I'll talk a little bit more ahead about those. And yeah, just to talk a little bit about the option to go Terraform infrastructure as code. This is one of the things I really like about Terraform. It's just infrastructure as code. So when you need to back up your infrastructure, theoretically, all you have to do is git push your the code itself. There are very good people that use Jenkins, for example, which is completely plausible and a very good option. But to be honest with you, it's mostly a personal preference because, first of all, I look at Jenkins and it looks like something coming out of the 90s, and not a huge fan. But also, on a more practical side, I'm a minimalist, and I want to decrease the amount of sysadmin work that I have to do. And the worst thing that I want to, the thing I don't want to happen to me is for me to come into the office thinking that I'm going to do some really cool recon on a client, and then all of a sudden there's a new critical CV on Jenkins, and I have to patch it, and I patch it, and I figure out it's broken. Now I have to fix everything up, go figure out where the last backup was. I'm not doing that. So yeah, really huge fan of Terraform, and yep. The next one is just the integration between Terraform and Ansible. Just to clarify, it's not like I'm an expert in these technologies, but the feeling I get is that Terraform tends to be better at deployment of infrastructure, and Ansible tends to be better at provisioning, installing software, and setting the server up. So there's a lot of discussion. Some people think one is best in the other, but some other people think the combination of the two is the best. And quite honestly, I've used it and haven't had an issue yet that I could think, oh, maybe I should have used more one or the other. And then there's some notes on infrastructure security. The most important thing when you have such infrastructure, especially deployed automatically, is you want it to be secure. Bear in mind, these are software that will be running the C2s and so on that give you access into actual infrastructure. So you want to be very careful with that and make sure you know what you're doing. One of the cool things, very easy to manage SSH keys throughout this whole thing. The version I'm using Azure as on the backend as my cloud provider. And the firewall is the network security group, NSG, and that's just a little part, as you can tell by the left column. There's a lot of number of lines there, but just an example. The first one will limit. That's for the resource C2 redirector. So for the redirectors, I will only allow SSH, and to be honest, I think pretty much all the VMs. I will only allow SSH from the operator public IP address, for example. And then the redirectors will accept both port 80s and 443 from anywhere. But there's a little trick that I will explain actually now in the misdirection part. What does that mean? So this is one of the cool things about these types of projects is that you can become very creative, and because there's no right way to do things, you can just do whatever you want that you find interesting. And one of the interesting stuff that I thought about was, if you notice, when I run it, there's some debug information there. You can tell there's a client network range that I supply. Now, the reason I do that is for the infrastructure to be able to tell the difference between what's coming from the network, the client network range, and what's coming from the rest of the internet. Now, if you're coming from the network range, the client network range, what you will see, and you try to access one of the IPs, in that case the 112 redirector, what you will see is the actual backend. I think this case is the payload redirector, so it's the payload backend server. That's the Apache that is there installed. Now, if you try to access it, I used my phone because I'm on 5G, so it's just easier to don't have to set up anything or just to move places. So just from my phone, you see a cannoli recipe, which is good if you want to play around with the blue team and just misguide them a little. It's always useful. So yeah, it's one of the interesting stuff that you can pull off by having these solutions. So in terms of DevOps, building the tools, compiling the tools that we use very often. I'm using GitHub Actions, and again, it's not like I sat down and I played with every single one of them out there and decided that GitHub Actions is the best. Not the case at all. But I like using, if I'm using GitHub already for my repos, for whatever, I use it for project management as well. It's kind of handy in that sense. When you pull, push stuff, it automatically creates stuff in there, which is super convenient. But if I can have all my tools in one spot, unless there is an amazing feature on some other option, I will tend to have all of them on one spot and just make my life easier. So that's why GitHub Actions was the option. Now, that being said, I've noticed some difficulties in developing, in writing workflows, just some things that don't sit perfectly with me. That might have changed since then, a few months that I checked that. But for example, the latest version, I want to say, of Visual Studio that you can use to build tools in GitHub Actions is, I think it's 2019. Whereas if you're using the Azure DevOps, I'm not sure if it's Azure DevOps or if it has a specific name, don't remember, but then it allows you for the more modern 2022 version. And overall, it kind of makes sense that Azure would make a better option for building at least C# tool, .NET stuff. So it kind of makes sense. So it's definitely something that I want to try and give it a go, but that's later down the line. So you can see here just an example of a workflow running. Now, if you look at the green sign over here, and you see here it says manually ran by Andre. I was confused when I read that because I never read that. I mean, I ran it manually, I think, the first couple of times when I was testing the thing. But ever since, it's just the infrastructure, the Python wrapper that runs it. But I then realized on the GitHub documentation that you can manually trigger a workflow run using the GitHub API. And that's basically what I'm doing. That's a call, a part of the Python wrapper, where I'm just obfuscating my API key, of course, but overall it's just more than obvious stuff. It's just some Python code that runs, triggers the workflow. Now, after you build a thing, the naming convention is you create what is called the payload. In this case, it's called artifacts. Now, in GitHub Actions, and I'm sure others, do provide input, not only input, which is useful here in terms of public IP addresses, but also allows you to define secrets. So if you want to put in your SSH key to then connect to the payload server and upload the artifact that you just built, then you do something along those lines. And yeah. Now, that is all about building your code. But when you're building your code, before building your code, you want to worry a little bit about the code itself. And the simplest example, you probably want to obfuscate stuff in it, but not to be easily detectable in signature-based kind of detections. So the way you try to do usually that is by using some sort of scripting capabilities, either PowerShell or Python, and you'll find a lot of very hacky ways where people will run scripts to find, for example, literal strings, anything between two double quotes. But if you think about it, that's a very hacky and bad way to do it. It can lead you, depending on the complexity of the software, to a lot of false positives. Interpolated strings is another type of strings that you cannot detect just by simply doing that kind of stuff. But also all types of details, like if you're expecting a keyword followed by, for example, if you want to update an in C#, you should, because the executable is actually IL code, intermediate language, and it keeps a lot of the names of the classes, methods, and all that stuff, namespaces. If you are looking like to replace a class name, and you're thinking about, oh, let me look for the name ABC, but ABC might be like in the middle of a string, so let me put space ABC space. But then you can find examples where the program, where there's two spaces, where there's a line break, when there's lots of stuff. Bottom line is you're trying to do it the hacky way, which might work, but it's not the best way. And that's where Roslyn comes in. After doing this type of stuff, I thought Roslyn was just a compiler. It turns out that it's actually defined as a .NET compiler platform. And that sounds very fancy, but basically what it means, it represents C#. It parses the code, which, if you think about it, it's the best tool to parse the code and interpret it. And most importantly, it parses the C# code and it generates a syntax tree, which then you can navigate, and you will have all these different types that will define specific stuff that you will then easily be able to find class names, to find the instances where they refer to that class name, method names, whatever you want, literal strings, interpolated strings, and all that stuff. So the syntax tree will contain syntax tokens, such as keywords, literals, and so on, syntax trivia, all the different types. There's different types for different types of comments, for example, and syntax nodes as well, language constructs, classes, namespaces, and all that. So that is the power of Roslyn. Now, just a quick warning. It sounds like, oh, I'm about to show you like a few slides on this stuff, and it sounds very straightforward, and oh yeah, it must be like easy to use. First of all, like, but there's a lot of stuff that I'm not talking about here because this is not a Roslyn tutorial. But I will give you really good references of places where I learned a lot about it. One of the things is you can write very simple code and look at the syntax visualizer. It's not hard to get to it from the menu. I don't remember right now because I've done it a few months ago, and now it's always there. So, but ping me later. I'll find on my notes or actually look at it. But yeah, so you can click on stuff, and I think there I was clicking on Hello World, and it immediately jumps, the visualizer jumps into the type that corresponds to that object, which is the string literal type. This is just an example for you to start getting like comfortable with the types and understanding how it all nests in together. But in order, the oversimplification here is that I just showed this, and everyone is probably expecting to open Visual Studio and find it. You actually have to install Visual Studio SDK to do that. If that was the only thing, that would be cool. But so the NuGet packages to be installed, there are quite a few. Let's say 4 or 5. I have to check my notes again. But they basically contain information for types, classes, libraries required to analyze, parse, and understand the C# code. Then you have multiple objects, literal string, interpolated string, syntax trivia, all that stuff that you kind of have to get used to. So it's a good idea to actually take a look at the visualizer. There is also, I didn't put it here, I forgot, but there's also a URL, a website that does that offline. So if you don't have Visual Studio for whatever reason, or just want to quickly just we'll go and check it, again, ping me later. Yeah, multiple workspace types, ad hoc workspace, MS Build workspace, Visual Studio workspace, depending on what you want to do, you'll have to use different ones. And also understand just what a workspace is, a solution, a project, documents, how they correlate with each other, and then how all the objects then come into the document object. Then you have learning how to navigate the syntax, which can be done in 3 ways. Link is the simplest way. Sorry. But not great performance, which is relevant if you're writing an analyzer, which Visual Studio is running every time you press a key. But then again, for our purposes, it's not really that bad. There's also Syntax Walker and Syntax Visitor. And Link is actually something, because I find the Syntax Walker a little bit more elegant, but I've been forced to go back to Link a few times just because of that last sentence, insufficient stack to continue executing the program safely. Now, if you've ever programmed using any sort of recursion, you know that if it gets too deep, then you start having trouble with the stack. And that's something that sometimes Syntax Walker will trouble you, and you'll have to revert to some sort of solution on Link. Another issue is all those objects are immutable objects. And that's something that you hear and you tend to forget really quick. But what that means is every time you actually change the code through programming, it actually creates a new instance of the object. So if you're keeping the old one, which is very common, you then struggle with, wait a minute, I just changed this. What happened? Why is this not changing? And you just have to figure out that you have to use that new object. So just some really, really good resources, and again, conferences that I would usually not attend. Developer more, like C#, I think. I want to say programmers, developers, but seem very focused on C#, don't know. But and Bsides Oslo, where Mark Randall and Eric Shearboom, I hope I'm pronouncing that right, but they talk about very deeply about it, and some other implementations that don't relate to security, but you understand the whole point of having these. Also, XPN has really good blog where he actually uses Azure DevOps. Which XPN is Adam Chester, amazing researcher. And actually, I do have the link for the syntax visualizer, which is that one, Roslyn Quoter. Again, I'll give you the QR code for the slides in the end, so you can access all this. So let's just show a demo of Roslyn. In this demo, it will just grab a seatbelt, and it will convert all literal strings and interpolated strings to capped uppercase letters. I'll just show you the code and everything. Just one sec. Okay, so this is basically the main code, and as you can see there, I'm loading the solution. It's going to just call. Let us just run through it. So it loads the solution. That's the seatbelt that I'm about to update and download. Then it creates an instance of the uppercase writer, which is an implementation of C# syntax rewriter. And you have those two visitors, interpolated string text and interpolated the literal string one. And all of those are executed once navigating through the whole syntax tree and calling out the visit method there. So then I just have to update everything. build the whole process, output the assembly to an executable locally, because again, this is all in memory, and then run it. And here you can see that I'm getting a fresh copy of seatbelt, and then I just run it. And you can see everything comes back in uppercase. That is very weird because I'm not moving it. Okay, okay. Now, there are some complications there. Things get trickier, I mean. The thing is, that is a very simple example, but it's the example, I wanted to show it because it's the easiest to visualize, because of the uppercase, of course. But what you actually want to do is to integrate, to grab that literal string or interpolated string and put it inside a decode method. Not only obfuscated somehow or encrypted, but also put it inside a decode method. Now, what that means is that you have to write the code for the decode method somewhere. Now, depending on the software, that could mean inside a namespace, inside a class, and just write another method. But it has to be code that is reachable throughout anywhere that has a text that has been obfuscated. So it makes you think it's not that straightforward. So. Now, just to clarify some goals, what you want to have is fresh infrastructure ready to go, fresh payloads ready to go, simple to deploy, easy to manage. But and for future development, what I want to do is having the infrastructure timeout for auto cleanup, because ideally, you don't want to stress too much about bringing down the infrastructure and just have it, the engagement is ending in 2 months, for example. You just set a date and it does it automatically. Of course, more C2s. Everything that it's being done is the redirection and everything right now is through IPs, not domain names. So that's a part. But I've seen that you can actually buy domain names. Probably generate a few random ones to test it out, but there are tools that will generate, if you give it some sort of context in terms of naming of company kind of thing, it will generate a few random names that are kind of related to it. So it's a better of disguise, but again, you want to automate all of that. Support to HTTPS, still not done. Also, phishing infrastructure support. I definitely want to add that. How long do I have? Okay. Now, a lot of people like solutions like GoFish, but personally, haven't had great experiences because the obvious thing about these types of tools is that you lose a little flexibility and control over what is sent. So a lot of spam filters will tend to become really good at detecting the minor things about how an email is developed. So you want to be very careful with that. And to that extent, I'm much of a bigger fan of developing the whole thing myself. Very quickly, Python code running that connects to an SMTP server I've done it in AWS before, but pretty sure you can do it anywhere else, to send an email, and then you control the whole body. That could be HTML, that could be just text, but you control everything, exactly everything that goes into that. And then just create the whole phishing site where you collect the credentials and so on, and make it look like something legit. quick conclusion. Good red team infrastructure design principles: resilience, security, easy to deploy. Good payload dev principles: obfuscation. Encryption is usually, not always, but usually an overkill. From experience bypassing EDRs, most of the times what you are actually trying, and it's really important for you to understand the goal here. What you're trying to bypass is automated static analysis, as in signature-based kind of detections. You can never stop a really good manual reverse engineer. So it might take them longer, but that's the point. You want them to take a little bit longer, but it's just for you to be able to then move laterally and get other machines. So it's very important to understand what is the purpose here, and more often than not, Zor encryption, Zor obfuscation, or encryption technically, with 1 byte key is more than enough. Code insertion to stop automated dynamic analysis. Don't have time, I would elaborate on that, so just ping me after. But IOC stripping, per compilation, per op, GUID insertion. You want to have that because you want to have the functionality of if something gets uploaded to VirusTotal, you want to be able to understand exactly which engagement were you on when you compiled that payload. And it's really good feedback as well for the client and for yourself. If you're in the middle of an engagement and one of your payloads gets uploaded, you know it's from this engagement and not the previous one or something like that. So you probably need some fresh payloads. You only get that kind of feedback if you have these GUID into your payload. And then, of course, the kill switch. The job is ethical hacking, and there's a very important part on the ethical word. And that also means respecting the client's time. Now, a lot of the times you assume, oh, but my infrastructure is gone, like, what do I care? You should care, because when a payload is triggered, is executed, and it starts running, you need to have a kill switch. Otherwise, what that does is starts a whole bunch of red flags and tickets throughout the whole company, and you're just wasting people's time unnecessarily, as opposed to it just checking if it's the time of the engagement, if it is, for example, if it is running on a computer in the domain that belongs to the client. So you definitely want to check those things. And when you want to check, for example, for domains, you don't want to put in the actual domain of the client in the payload, because that's a hint that a client X might have been compromised. So what you want to do is, if you understand password storage, is pretty much something like that. It's a bit extreme to salt it, but what you want to have is a hash of it. So you grab the domain where that computer belongs, you hash it, you compare it with your hash, and that's only if it matches, then you run. But if you take anything from this talk, let it be the following. Never send a human to do a machine's job, Agent Smith. So I hope that you've learned that today. You can grab the slides on that QR code. Again, I'm reachable if you want to check my previous presentations. So thank you very much for coming.
Thank you very much.
Thanks, man. Really appreciate it.
Yeah. We all appreciate it too. Are you sticking around if people have some questions?
Yes.
Fantastic.
Dinner as well.
Yeah, here for dinner as well. Great.